Redistribution between EIGRP and OSPF. Build this topology. We will use these routers with iOS 15.2. Instead of using serial 000, I will use serial 30. And instead of using serial 001, I will use serial 31. Start all devices, all nodes. In this scenario, R1 and R2 are running EIGRP, while R2 is the OSPF Autonomous System Border Router ASBR, consisting of areas 0, 10, and 20. You need to configure R2 to enable these two routing protocols to interact to allow full connectivity between all networks. R1 is running EIGRP and R3 is running multi-area OSPF. Your task is to configure redistribution on R2 to enable these two routing protocols to interact, allowing full connectivity between all networks. Required resources for a real app: configure loopbacks and assign addresses. R1. Okay, first of all, configure all these loopback interfaces. Configure terminal interface loopback 0, IP address, loopback 48, IP address, .49, .50, .51, .70, 70.1. Now, configure the serial interface, in my case serial 30, on this network. Should be 12.1. Subnet mask 24. Clock rate more question, use the highest value if you want. Then set the bandwidth only to 64 kilobits per second, so the clock rate can be also 64. So the bandwidth (64 kilobits per second), then no shutdown. Part 2. The loopback interfaces and the serial interfaces. Serial 30 on 12.0 network and serial 31 on 23.0 network. Loopback 100 and loopback 0. Configure terminal interface loopback 0, IP address, subnet mask loopback 100, IP address, serial 0, in my case serial 30, the IP address 12.2, subnet mask 24, bandwidth 64, no shutdown. Then serial 1, serial 31, the IP address on 23 network 23.2, subnet mask 24, clock rate 64,000, so bandwidth 64 kilobits per second, then no shutdown. R3, all these loopback interfaces, and serial interface serial 31 placed on this network 23.0 network. Configure terminal interface loopback 0. The IP address loopback 8 IP address nine 9.1 10 10.1 11 11.1 20 20.1 25 25.1 30 30.1 35 35.1 40 40.1 and serial 01, in my case serial 31 serial 31 IP address subnet mask 24 the bad white no shutdown. Then verify you can ping across the serial links when you are finished. Is the following TCL script. Okay. Okay, use this script. Okay, go to R1. Go to R1 and TCL shell. Enter. Okay, remember the spaces are critical. Copy and right click to paste on the command line interface. Then press enter. Okay, some are successful and another destination IP address failed. Which pings are successful and why? At this point, only directly connected interfaces will be successful. For example, R1 should be successfully pinning the first 8 IP addresses from 172.16.1.1 to 172.16.12.2. In the list and failing for all other IP addresses as they are not on directly connected networks. Configure EIGRP. Configure R1 and R2 to run EIGRP in Autonomous System 1. On R1, add in all connected interfaces either with classful network commands or with wildcard mask. I prefer to use wildcard masks and use a classful network statement on R2 and disable automatic summarization. Okay, for example, on R1, exit from TCL shell, exit, and show IP configure terminal, Autonomous System 1, router EIGRP1, disable the automatic summarization, no auto summary, and show the directly connected networks do show IP route connected. And notify all directly connected networks. The wildcard mask for this, for 24, (12.0.24), this, and then the another loopbacks for the 8.0.24, 49, 50, 51, and 70. Also, you can do this. It's the same configuration like this and like this. Now configure R2. Exit router. Okay, and on router EIGRP, only configure loopback 0 172.16.2.0 network. Okay, this and these two networks place it on EIGRP Autonomous System 1. Only these two networks, the loopback network and the serial network. Rather EIGRP1, no auto summary, do show IP route connect. Okay, only the loopback 0 network and serial 0 network. Network 20 and the wildcard for 24. And 12.0 24. Okay, only these two networks placed on EIGRP Autonomous System 1. Okay, for example, on R1, verify the neighbors for EIGRP and show IP EIGRP neighbor. And you can see R2. Show IP root EIGRP. Okay, the EIGRP routing protocol is notifying this network 2.0. This network for the loopback 0 interface, it's not showing this another loopback 100 or serial 31 network because these networks are placed on OSPF. Okay, so don't worry about this output. This is very good. On R2 verify and show IP EIGRP neighbor. This is R1 and show IP root EIGRP. This is the loopback interfaces on R1. Okay, 1, 2, 3, 4, 5, 6. 6. Okay. Verify that R1 and R2 can reach all the networks in the EIGRP routing domain. Okay, go to R1, TCL shell, and paste this script. Enter. All success. These are the loopback on R1. This is the serial interface on R1, serial interface on R2, and loopback interface on R2. Manually summarized with EIGRP. To make routing updates more efficient and ultimately reduce the size of routing tables, contiguous EIGRP routes can be summarized out an interface by using the IP summary address EIGRP, the autonomous system network and mask interface configuration command. On R1, advertise one supernet route summarizing the networks of loopback 48, 49 to R2. Okay, use this command on serial 0 on R1. Okay, this is R1 exit. On R2, you can see 48 and 49 with subnet mask 24. Okay, both with 24. Go to R1 and configure the summarization. Configure terminal interface. In my case, here 30 IP summary address EIGRP1 on 82.168.48.0 255 255 254.0. This is the summarization for 48 and 49. Okay. The notification and on R2 show IP route EIGRP, and now you can see only 48.0 with 23 subnet mask. And also verify on R1 to show IP routes EIGRP. And look at this. You have a new entry 192.168.48.023. It's a summary and the exit interface null 0. Notice how EIGRP now has a route to the summarized address going to the null 0 interface in the routing table. Okay, verify the specifics for the summarized routes using the show IP routes 192.168.48.0 and subnet mask command on R1. Okay, do show IP route 192.168.48.0 to 55 to 55 to 54.0. Okay, this is the entry. This is a supernet EIGRP1 distance 5. Directly connected via null 0 interface. Notice the low administrative distance 80 for this route. Why does EIGRP and the summarized route pointing the null 0 interface with a low administrative distance? EIGRP automatically creates a summary route to the null 0 interface because it is the source of the summary. It has knowledge of all existing subnets advertised by the summary routes. If it receives a packet destinated to the summary route, but the route doesn't If it receives a packet designated to the summary route, but the route does exist, then the packet will be dropped, sent to null 0, rather than being forwarded out to another default gateway. The null 0 interface is assigned and advertised to neighbors with an administrative distance of 5. The low administrative distance ensures the summary route is preferred over other routing protocols, BGP, EIGRP, and OSPF. However, routes with administrative distance of 4 or less connected interfaces, static routes, would be preferred over the null 0 route. Okay, remember on R2 you have only one entry for the networks. Notice how the routing table is slightly smaller as the entry to 192.168.49.0 is now missing. However, 192.168.49.1 is still reachable due to the summarized route 192.168.48.023. Verify by pinning the lookup 49 interface from R2. Okay, ping the loopback interface on R1, the 49 loopback with this IP address 49.1. Success. Now configure OSPF. By default, loopback interfaces are advertised as a host route with a 32 mask. To advertise them as network routes, the loopback interface network type must be changed point to point. In this step, you will advertise the loopback interfaces as point to point and configure multi-area OSPF between R2 and R3. On R2, configure loopback 100 interface as a point to point network. R2 interface loopback 100. IP OSPF network point to point to change the network type. Okay, go to R2. Remember, you have loopback 100. and serial 31 configuration. You need to configure these two interfaces. Configure terminal interface loopback 100. IP OSPF network point to point exit. Okay, then advertise on OSPF router OSPF process ID 1 to show IP route connected. Okay, loopback 0 on EIGRP, serial 0 on EIGRP, configure serial 31 on OSPF and loopback 100 on OSPF. Network 16.23 0 wildcard 24 on area 0. Okay, this is OSPF area 0. Okay, it's better. The process ID is 1, but area is 0. Okay, OSPF process ID with area 10 in this case. 20 area 20. Okay, that is better. And 23, this network is placed on area 0. Loopback 100 placed on area 10. Area 10. Now configure R3. Change the network type for loopback 0 and range interfaces from loopback 8 to 11. Change the network type to point-to-point. R3. Exit interface loopback 0. IP OSPF network point-to-point. OSPF. Exit and the range interface range loopback 8 to 11 and apply the network type to point-to-point. Exit. Also, this range from 20 to 20, 25, 30, 35, and 40. Interface range loopback 20, loopback 25, loopback 30, loopback 35, and loopback 40. The network type, then exit. Now configure OSPF, process ID 1, router OSPF 1, to show IP route connected. Okay, these are all directly connected networks on R3, but configure on the appropriate area. Okay. Loopback 0, 20, 25, 30, 35, and 40 placed on area 0, and loopback 8, 9, 10, and 11 on area 20. Remember that. Okay, start with this. This is the loopback 0. Area 0. Serial 31 is 23.0, also in area 0. Okay, this is the network adjacency, 8, 9, 10, and 11 on area 20. 8, 9, 10, and 11 on area 20. Eight dot 0 on area 20. Nine dot 0 on 20. 10 dot 0 on 20, and 11 dot 0 on 20. 20, 25, 30, 35, and 40 on area 0. 20, 25, 30, 35, and 40 on area 0. 20, area 0. 25, area 0, 30, area 0, 35, area 0, and 40, area 0. Okay, go to R2 and verify the network. R2 and show IP OSPF network. This is R3. Okay, very nice. Show IP root OSPF. Now you can see the network 3.0. 3.0 is loopback 0 on R3. 8, 9, 10, and 11 inter area, because it's placed on area 20. All these loopback interfaces. And 20, 25, 30, 35, and 40, all these loopback interfaces. So it's very well configured. On R3, also verify and show IP OSPF network. This is R2. Show IP root OSPF. Okay, inter area 100. 100 inter area because it's placed on area 10. This loopback. Okay, only one. Very nice. Verify that R1 and R2 can reach all of the networks in the OSPF routing domain. Okay, go to I think this should be verified that R2 and R3 can reach all the networks in the OSPF routing domain. And go to R2 or R3. For example, R3, verify using this TCL script. Okay, because if you will use R1, these pings will fail for now. Okay, first of all try on R3. Go to R3, TCL shell, copy this script, then apply it. Copy and right click to paste. Enter. All successful. Okay, you are testing the connectivity for, this is the loopback on R2, serial interfaces between R2 and R3, this is the loopback interfaces on R3. Okay. All pings should be successful. Troubleshoot if necessary. For example, on R2 should be the same result. TCL shell, copy this script, right click to paste, enter. All success. Okay. But if you will do this on R1, pings will fail. Okay. And TCL shell, copy this script and right click to paste, enter. Okay, these pings will fail because you need to configure the redistribution on R2 to join EIGRP with OSPF. Okay. Okay, and now summarize OSPF areas in the area border router, ABR. Review the R2 routing table. Notice the inter-area routes of inter-area for the R3 loopbacks in area 20. R2, exit, and show IP routes, OSPF. Look at this inter-area 8.0, 9.0, 10.0, and 11.0. Where can you summarize in OSPF? In OSPF, you can summarize at the Area Border Router, ABR, and Autonomous System Border Router, ASBR. Inter-area summary LSAs created in the ABR are embedded in the Type 3 LSAs. External summary LSAs created at the ASBR are embedded in Type 5 LSAs. Okay, then these four routes can be summarized in a single inter-area route using the area range network mask command on the ABR R3. Okay. R3 is the area border router for area 20 and for area 0. Is the ABR. So you can configure the summarization on R3. Go to R3, exit from the TCL shell, configure terminal, enter to router OSPF process 1, and summarize all networks on area 20 that are contiguous, A9, 10, and 11. Rather OSPF. Sorry, area 20 summarize the range from this summarized network, the supernet, okay, with 8.0 with subnet mask 252.0 includes 8.0, 9.0, 10.0, and 11.0. Enter. Okay, now go back to R2 and verify. Show IP route OSPF. Now you will see only 8.0 but using subnet mask 22. This is before and this is after. Compare and contrast OSPF in EIGRP in terms where summarization takes place. EIGRP allows summarization at any EIGRP router interface in the domain. OSPF can summarize only at the ABR and the ASBR. Configure mutual redistribution between OSPF and EIGRP. Notice that R2 is the only router with knowledge of all routes EIGRP and OSPF. In the topology at this point, because it is involved with both routing protocols, next you will redistribute the EIGRP routes into OSPF and the OSPF routes into EIGRP. To redistribute the EIGRP routes into OSPF, on R2 issue the redistribute EIGRP1 subnets command. The subnets command is necessary because by default OSPF only redistributes classful networks and supernets. Okay, go to R2 and configure terminal router OSPF process 1, redistribute EIGRP autonomous system 1 and subnets, then exit. Okay, you are entering to OSPF and redistributing EIGRP on R2 that is in the middle of EIGRP and OSPF. A default seed metric is not required for OSPF. Redistributed routes are assigned a metric of 20 by default. To redistribute the OSPF routes into EIGRP, on R2 issue the redistribute OSPF1 metric 10,100, 255, 1, and 1,500 common. Unlike OSPF, EIGRP must specify the metric associated to the redistributed routes. The command tells EIGRP to redistribute OSPF process 1 with these metrics: bandwidth of 10,000, delay of 100, reliability 255 of 255, and load 1 of 255, and MTU of 1,500. EIGRP requires a seed metric. Okay, router EIGRP1, but on R2. Okay, enter to EIGRP, router EIGRP1, redistribute OSPF process ID 1 with this metric 10,100, 255, 1, and 1,500. Then exit. Okay, for example, review the command again, router EIGRP1, redistribute OSPF1, the metric, mark question to view the options. You can set the bandwidth metric in kilobits per second. So you are using 10,000 kilobits per second. That means 10 megabits per second. Okay. Mark question again and you can set the EIGRP delay metric in 10 microsecond units. If you are using 110 microseconds. Okay, 255. Sorry, mark question. From 0 to 55 is the EIGRP reliability metric, where 255 is the 100% reliable. Okay, 255, 100% reliable. Mark question 1 to 55, EIGRP effective bandwidth metric or load, where 255 is 100% loaded. Okay, only one low load. Mark question from 1 to 65,000 EIGRP MTU of the path. Basically, use the MTU to 1,500. Okay, this is the specific configuration. I just apply it. Alternatively, you can also set a default seed metric with default metric commands. On R2, set the default metric, okay, and then redistribute OSPF1. Okay, this is the same command like this. Okay, router configuration modes. Okay, on R2, verify show IP protocols. Do show IP protocols. Okay, routing protocol EIGRP1, but you are redistributing OSPF1. And now you have routing protocol in OSPF process ID1, and you are redistributing external routes from EIGRP Autonomous System 1. Include subnets in the redistribution. Now, go to R1 and verify the routing table. Exit from TCL shell and show IP routes. And you can see all. A directly connected network, loopback 0, EIGRP network 2.0 that is placed on this loopback 0 and the same autonomous system EIGRP1. And all these external external EIGRP DEX 3.0 is this loopback 0 on R3. Directly connected network 12.0 on serial interface, this network. All this EIGRP external 23.0, 100, 8, 20, 25, 30, 35, and 40. All the loopback interfaces on R2 and R3. And 48.0 is the summary null 0 interface, the summary of 48 and 49. And any other directly connected networks, the loopback on the local router R1. Loopback interfaces on the local router R1. Okay, redistributed OSPF routes display of R1 as DEX EIGRP external EIGRP routes. And go to R3 and show IP routes. go to R3, do show IP routes. Now you can see all this. Redistributed EIGRP routes are tagged in the R3 routing table as O external 2, which means that they are OSPF external type 2. Type 2 is the default OSPF external type. Okay, this is R3, OSPF external 2, 1.0 and 2.0. 1.0 is loopback 0 on R1 and 2.0 loopback 0 on R2. Directly connected network, loopback on the local router, OSPF external 2, 12.0. This is this network between R1 and R2. Directly connected network, the connection between R2 and R3. OSPF inter area 100, the loopback on R2. This loopback, OSPF 8.0, that is the summarization of 8, 9, 10, and 11 on area 20. All directly connected networks, and OSPF external 2, 48, 50, 51, and 70. They are these loopback interfaces on R1. 48 and 49 summarized 50, 51, and 70. Verify full connectivity from R1 TCL shell and verify with this script and apply this. R1, right click to paste, enter. All should be success. Go to R3 and TCL shell. Copy again this and paste, right click, enter. All success. Finally, summarize external routes into OSPF and at the Autonomous System Border Router ASBR. You cannot summarize routes redistributed into OSPF using the arrange command. This command is effective only on routes internal to the specified area. Instead, use the OSPF summary address network mask command. Before you make any changes, display the R3, the OSPF routes in the routing table, and list only those routes that have an external to type metric. Okay, go to R3, exit from the TCL shell, and show IP route OSPF pipe include E2. Okay, show all the OSPF external to routes, and you can see this 48.0, 50.0, 51.0, and 70.0. And you can see this 48.0, 50.0, and 51.0 routes. Okay, these routes are the loopbacks on R1. Notice the external routes for the R1 loopback interfaces 48, 50, and 51. Loopbacks 48 and 49 were previously summarized in EIGRP. They will be included when redistributing the EIGRP into OSPF. Which masks should you use to summarize all loopbacks 48, 50, 51 to one prefix? Okay, and use the 22-bit mask with the network address of 192.168.48.0. You can summarize this all into one supernet on R2 using the following commands: access to router OSPF1 and summarize the address 192.168.48.0 255.255.252.0. Go to R2, exit router OSPF1 summary dash address 192.168.48.0 255.255.252.0. Exit and go to R3 and verify. Show IP root OSPF includes external type 2. Now you will see 192.168.48.0 with subnet mask 22, and this includes 48.0, 23.50.0.24 and 51.0.24. Very nice. What would happen if loopback 50 on R1 were to become unreachable by R2? R2 would still advertise a 22-bit summary address to R3 until all the subnets included in the summary become inaccessible. Would data destined to 192.168.50.0 from R3 still be sent to R2? Yes, data packets destined for 192.168.50.0.24 from R3 will still be sent to R2. Would data destined for 192.168.50.0.24 from R2 continue to be sent to R1? No, because R2 has no prefixes longer than 22 bits that match the 192.168.50.0.24 subnet. Packets will be routed to the null zero virtual interface on R2. If you are ensured to outcome, shut down the interface on R1. Issue the ICMP traceroute command to 192.168.50.1 from R3 and then from R2. Check your output against the output analysis in Appendix A. Remember to issue the no shutdown command when you are finished checking. Okay, go to R1, exit from the TCL shell, configure terminal, interface, loopback 50, and shut down. Okay, change state to administratively down, and go to R2, do show IP routes. Okay, 50 is not advertised here. No 50.0 network, and go to R3, show IP route OSPF, show IP route. Okay, but here on this route 192.168.4.0.22 network is here is included the route 50.0. 50.0 network is included here. Okay. Okay, and from R3 use the trace route to 192.168.50.1. Okay, from R3 trace route to loopback 50, enter. This is the R2 router, the serial interface on R2 router, but the destination IP address is not reachable. go to R2 and test and trace route 192.168.50.1. Okay, and will not be possible to reach the host. Okay, go to R1 and re-establish the interface. Interface feedback 50, no shutdown. Go to R3, success. Go to R2, success. Is this a desirable outcome? Explain. It is a desirable outcome because summarization allows routing tables to be reduced in size. However, a result which sometimes may be considered mildly undesirable is that data traffic is forwarded beyond where it would be forwarded without summarization. The resulting configuration is required for lab 4.2.